Section 11.3 is the area of polygons. So we're going to start with some simple quadrilaterals, and they're going to be rhombuses and kites. So the area of a rhombus or a kite with diagonals D1 and D2. So here's one of our diagonals, and here's one of our others, is simply just A is equal to 1/2 D1 times D2. So on the first one here, find the area of each rhombus or kite. So we're just going to use our formula. So area is equal to 1/2 D1 times D2. So in this case here, we're going to have one of our diagonals is 5 feet. The other one is 11 feet. And if we take that and plug it into our calculator, we'll get 27.5. And again, our units is feet. And remember, area is always squared, so it'll be feet squared. The second one, same thing. We're going to use the formula. 1/2 D1 times D2. Doesn't matter which one you call D1 or D2. All right, so we're going to have 1/2 of 24 times 10. And again, if you can plug that one into your calculator, or that one you can actually kind of figure out. Half of 24 would be 12. 12 times 10 would be 120. And then this time it's millimeters squared. All right. So next, finding angle measures in regular polygons. So we're going to need all of these here when we start finding the area. So what they're going to kind of show you here is how to kind of look at these. So the center of a regular polygon is the center of its circumscribed circle. So circumscribed means that it's on the outside. All right. So the circle is outside, and the polygon is actually called inscribed because it's inside the circle. All right. So the center of a regular polygon is the center of its inscribed circle. The distance from the center to any side of a regular polygon. So we're going to the side here. And remember, it's going to go to the center. All right. It's going to go to the center of one of the sides. So it's going to bisect the angle there, which is our central angle, which we'll talk about here in a second. And it also will bisect this side MN. The two that are the radii are this one here and this one here. So the distance from the center to any side of a regular polygon is called the apothem. So that's a new word for you, of a regular polygon. A central angle, now that's something that we covered in chapter 7, I believe, is formed by the two radii, which I just showed you. Okay. Drawn to consecutive vertices. So remember, vertices is where two lines meet. Excuse me. And to find the measure of the central angle, we're just going to divide 360 by the number of sides. All right, which we'll see here in our next example. So in the diagram, polygon A, B, C, D, E, F, G, H, J, K is a regular decagon inscribed in circle P. So find each angle measure. So the measure angle KPJ, so KPJ, and again, that's using the two radii there. So we know that's going to make it be a central angle. So the KPJ is a central angle. So we're going to take our 360 and divide it by the number of sides. Remember, a decagon is 10-sided. If you don't remember, you can just go ahead and count them. And that would give us 36 degrees. All right. Now the measure of LPK, So L, P, K. So it's taking the apothem. So remember, the apothem cuts the side and it cuts the angle. It bisects it. So since PL, the line segment PL, is an apothem, it bisects angle KPJ. So remember, bisect means it cuts it in half. So it would equal, I don't know what I keep doing. I keep hitting something and I don't know what's doing it. I had to restart once before, so hopefully I don't do it again. So that would be 1/2 of 36 degrees, or 18 degrees. Okay, and then finally the last one here. Now remember what's happening here. All right, the measure of angle LJP. So we're going to take this one right here, and we need this angle here. Now remember, this one here is going to be 90, and we just said that this one here was 18 degrees. So remember, this triangle here, this little triangle there, all triangles equal 180 degrees, right? So on that one there, what we'll be able to say is that the measure of angle LJP is 180 degrees minus, well, we have our right angle there, which is 90 degrees, and then we have our 18 degrees there. All right, and if we plug that into our calculator, we'll find that the measure angle LJP is 72 degrees. Okay, so now we need all of that here to be able to find the area of regular polygons. So the area of a regular polygon, in this case, the area of a regular n-gon, remember, we had special names for like the first couple, quadrilateral, pentagon, hexagon, heptagon, etc. After that, those insides. So the area of a regular n-gon with side length S. So what it's telling us here is that this here, that length is S. But in this case here, we would have all of these sides are length S. So we would just be able to take that side of S, and N is the number of sides, and we would multiply those together. So that's our perimeter. Our perimeter is just N times S. Okay. So, and the A is our apothem. So it's 1/2 the product of the apothem and the perimeter P. So let's see here. I think I better change the color here because I have green ones there. So a regular hexagon is inscribed in a circle with a diameter of 32 units. All right, find the area of the hexagon. So the hexagon is 6 sides. So we know we're gonna, once we find this side here, we're just gonna be able to use that and multiply it by 6. So on these ones here, now we're going to see stuff that we saw in chapter 9. So remember, I'm going to take 2 radii here. Okay, so there's that one there, and there's that one there. Well, the diameter is 32, so I know that this, the radius is 16. So first thing we need here is we need our central angle. Well, our central angle on this one here is 360. And we're going to divide that by the number of sides, which is 6 for a hexagon. And that would give us 60 degrees. Okay. So if we look at that, then we know that half of it So I'm going to just take this part right here, and I'll draw it a little bigger here. So we know that half of that is going to be 30 degrees, right? So this here is going to be 60 degrees. So now we have one of our special right triangles. Remember the 30, 60, 90? And this time I'm going to, since our A is our apothem, that's going to be this one right here. So I'm going to use a different one. I'm going to say this here is 16. So remember, I could say this is opposite the 30 was x. Here I could call this as 2x. And this here would be x times the square root of 3. All right, remember that was a formula that we had for a special right triangle. We had two of them. We had the 30, 60, 90, and we had the 45, 45, 90. So on this one here, we know if you look at it, we don't know what this one here is, right? We don't know what this one here is, but we can solve for our x here. So on here, we can say that x is equal to 8. So that would make this here be 8. And this would make this here be 8 times the square root of 3. Again, this is our apothem, which is what we need. All right? So now if this side right here is 8, that's just that part right there, right? So if we have to find the whole side. Sometimes they'll give us the side, sometimes they won't. So if we take the whole thing, it's going to be 16, right? So we can say then using our formula that the apothem is, the area is 1/2 the apothem times the perimeter, or we can say it's 1/2, in this case, 8 times the square root of 3, right? And then our perimeter is, that total length there is 16, right? So we're going to have 6, which is the number of sides, times 16. All right. And if you plug that into your calculator, you would find that you would get 665 and 11 hundredths. And since they call it units, we're just going to put it as units squared. All right. Or you could write out square units, however you want to do that. I was just using u squared. Okay. So on this one here, we had to find the side. On this next one, so our last example, a mirror in the shape of a regular nonagon. Remember, nonagon is 9 sides. You could always count the sides if you're not sure. And it has 6-inch sides. So what is the area of the mirror? So on this one here, I'm going to have to kind of draw everything now. Here's the center of the circle. All right, and I'm going to take one of these, and I'm going to draw my 2 radii. So then that is going to give me my central angle. Is going to be 360 divided by 9, which will give us 40. All right. Now that's the whole thing, but remember, I need an apothem, so I have to draw an apothem here. So I'm going to draw an apothem there. So I want you to think about it here, and I think I do have enough room here. So remember, the apothem bisects that central angle. So since our central angle was 40 degrees, we know that this is going to be 20 degrees now, right? And now here's our apothem. And since it bisected that side there too, we know we're going to have 3 there. Okay? So on this one here now, remember, you have to look, and again, this is chapter 9 stuff that we just did, ladies and gentlemen. So remember, we had SOHCAHTOA, or some old hippie caught another hippie tripping on acid, however you want to remember it. So I have this angle here. Remember, I can draw an arrow to the opposite side. All right. This here would be my hypotenuse right here, right? But I don't need that one because I need A, which is my adjacent side. So which one uses the opposite and the adjacent? All right. So if you don't remember, write it down if you have to. So, well, the one that uses the opposite and the adjacent is that one there. So we can say tangent. So we can say that the tangent of 20 degrees is equal to the opposite over the adjacent, which is A. All right? Or, remember, I told you if the A is on the bottom, I suggested you just flip them, right? Switch them. So we can say that A is equal to 3 divided by the tangent of 20 degrees. And so we're going to use that and we're going to plug that in. So now our formula, again, is 1/2 the apothem times the perimeter. So in this case, it's 1/2. Our apothem is 3 divided by the tangent of 20 degrees. Okay, and I would suggest that you put that into parentheses just like I did there. And then we have the number of sides is 9. Each side length here is 6. And if I plug that into my calculator, ladies and gentlemen, I should on this one here get 222.5 square inches or inches squared. I like to always use the inches squared. So I'm going to put inches squared. That's it. So just remember, when you're looking at these ones here, look at what you need. All right. Most of the time, you're going to use tangent to figure that out. And that's it. Okay. So good luck. I'll probably have to show you a couple of quick things tomorrow too. But you should be able to get this done, ladies and gentlemen.